In this video, we're going to talk about 5.3 Objective 1, where we identify and explain basic aspects of the central limit theorem and related notation. Question 1 says large samples of the same size are randomly selected from a very large population that may or may not have a normal distribution. What does the central limit theorem tell us about the distribution of the means from those samples? The means of the samples will have a distribution that is approximately a normal distribution. We'll talk more about what that normal distribution will look like here shortly. What is the central limit theorem and when does it apply? Suppose that many random samples of size n for a variable are taken and the distribution of means of each sample is recorded. Select all statements that are part of the central limit theorem below. It's not A. The distribution of means will be approximately a normal distribution. The mean of the distribution of means approaches the population mean mu, and the standard deviation of the distribution of means approaches sigma divided by the square root of n, where sigma is the standard deviation of the population, are the three things that we need to remember. So central limit theorem tells us that x bar is distributed normally with a mean of mu and a standard deviation of sigma divided by the square root of n, whereas x is distributed normally like that. So what that tells us is when we're going to find z values for x bars, it's going to look like this, as opposed to the z values here are going to look like this. That's what that tells us. When does the central limit apply? It applies for suitably large samples. Typically, the threshold is n is greater than 30. And the central limit theorem applies to variables with any distribution, not necessarily a normal distribution. So that's it. Come back next time and talk about 5.3 Objective 2. See you for the next video.